Hello, everyone. My name is Guang Wang. I'm a PhD student from Rutgers University. Today is my honor to share our recent work with you. The title of the paper is Understanding User Behavior in Car-sharing Services Through the Lens of Mobility, Mixing Qualitative and Quantitative Studies. This is the joint work between Rutgers University, Beijing Jiaotong University, and Southeast University. I will introduce our work following this outline. Let's go into the introduction first. In recent years, we have been witnessing a rapid increase of sharing economy. For example, co-working, freelancing, peer-to-peer lending, and shared mobility. In these sharing economy applications, users play a critical role. So understanding user behavior is very important to upgrade sharing economy applications. And in this paper, we will focus on one of the innovative shared mobility, the car sharing. The reason is that during the past decade, the number of car sharing users has significantly increased from about 1 million to over 20 million. Now, there are over 600 cities have car sharing services with over 9,000 million revenue. There are many car sharing operators around the world. For example, the UbiComp, BlueSG, and Car2Go. As we can see from this figure, there are multiple parties in the car sharing services, including operators who collect and manage the user information and the vehicle information and match users and vehicles. Users need to download an app to use the car sharing services. There are service stations for parking the shared vehicles, and these parties will interact with each other in the system. And understanding user behavior in car sharing is important for many different aspects. For example, the new findings discovery, system enhancement, and for better user experiences. And nowadays, with the development of ubiquitous communication and sensing technologies, we are fortunate to have access to both the attitude-free and attitude-aware data, which provides us a new way to understand user behavior through the lens of mobility. Hence, in this work, we aim to uncover comprehensive user behavior in car sharing from different aspects. And we try to answer 3 research questions. The first research question is what's the people's attitude to car sharing services? And the second question is who are more likely to use car sharing services? And when, where, why, how long, how regular they will use the car sharing services. And the last research question is what are the similarities and differences for the car sharing usages in different cities? To answer those 3 research questions, in this paper, we adopt a mixed methods approach, which combines an online survey and locked order data analysis. We collect 185 questionnaires, and about 37% of them are from the female participants. And we also utilize the large-scale real-world car sharing operation data with over 500,000 usage records from 3 Chinese cities, and about 20% of the users are female. And based on our online survey, we report some results. We found over 84% of the participants are willing to use car sharing services. And we found that most people use car sharing for traveling instead of commuting. We also studied the reasons that may prevent users from car sharing services. And so we found that the inconvenience would be the most important reason. For example, about 60% of the participants think hard to find vehicles and hard to return vehicles will cause them not to use car sharing. Finally, we also found about half of the participants express optimistic attitude toward car sharing, and about 40% of the participants have a neutral attitude, which means it may be a promising mobility mode in the future. And we also report our results based on the data-driven analysis. we first studied where and how long users use car sharing. We found the pickup and return patterns are highly dynamic in different hours of different days, and the usage patterns on weekends are also different from that on weekdays. And we also found that about half of the car sharing usages are within 5 hours, and about 85% of the usages are in 15 hours. Even though most per use time is shorter than 10 hours, there are several surges in long durations. For example, 15 hours, 24 hours, and 48 hours, and 63 hours. We further investigate when these surges happen, and we found that they all happen in the 3 special pricing packages durations. And we then study where users use car sharing. We can see that about 45% of the service stations have no neighbor stations within 1 kilometer, which indicates that they have low connectivities to other service stations. One direct implication is that users need to return vehicles to a remote station if there is no parking space in the dedicated station, which may potentially lead to poor user experience and cause low penetration. And we also found about 50% of the car sharing usages happen in only 20% of the service stations, and over 74% of the usages are in only 40% of the service stations, which indicates that there is an unbalanced usage phenomenon among different stations. This unbalanced phenomenon can potentially result in the vehicles in high-demand stations are frequently used, while some vehicles in unpopular stations will be rarely used, which may pose huge challenges for vehicle maintenance management. And we then study the aggregate pickup phenomenon. And here, each circle stands for a car sharing service station, and the size of the circles means the number of pickups activities in the station. We found that there are several stations with very high car sharing usages, and we found that they are all located in the IT industry bases and the CBD area. And we further study the fine-grained usages during 9 to 10 a.m. And the blue point means there are more returns than pickups in these stations. And the red point indicates there are more pickups than returns in these stations. And we found that there are more returns in IT industry bases and the CBD areas. For example, the top 5 stations with the most vehicle net flows are in the IT industry bases and the CBD area. And we then introduced the entropy and conditional entropy to quantify the regularity of car sharing users' user behavior, which are indicators to show whether car sharing users have stable user behavior and whether their usages are predictable. If users' original pickup station is null, the destination conditional entropy is very low, which means their destination stations are more stable and may be predicted. Moreover, the returning time conditional entropy for almost all users is less than 0.5, which indicates their returning time is easy to predict. And we also found about 73% of the users visited no more than 2 service stations, which potentially indicates they have stable usage and revisitation behavior. We also study the age-related usage patterns, and we found that about 92% of the users are between 18 years old to 38 years old, and among all users, only 19% of the users are female. And we found that the users between 27 to 29 years old have the highest usage, and they usually use the casualing during 6 to 8 p.m. And we also found that for the young users and elder users, they have different usage patterns in different hours, and they also have different usage patterns in weekends and weekdays. For example, for the users between 18 to 44 years old, they usually use the casualing during the weekday usually rush hours. For example, the 6 to 8 p.m. And we then study the gender-related user patterns. And we found female users have more stable destinations than male users, since more female users have a similar have a smaller entropy, and their usage patterns are more regular. And we also found female users and male users have usually used the casualing in different locations. For example, the top 3 popular service stations for male users are all located in the IT industry bases, which indicates most male users may work in the IT companies. However, the top 3 service stations for female users are in the CBD area and the financial harbor, which potentially indicates that females who work in the business companies have higher short vehicle usage demand, which can provide us a guideline to deploy the service station for female users and male users. And we then further study the user behavior in different cities, and we compare the user behavior in Beijing and Fuzhou and Lanzhou, and we found that even though there are some similar usage patterns, for example, the highly predictable usage patterns, and many user behaviors in Fuzhou and Lanzhou is different from that of Beijing. For example, the temporal patterns in Fuzhou and Lanzhou are different from that in Beijing. Hence, we still do not have sufficient evidence to claim that our findings are generalizable to other cities or countries. So more comprehensive studies should be conducted in the future. And so we also compare the spatial temporal patterns from different aspects, considering the car sharing and bike sharing and taxi and car rental. And so we found that car sharing is essentially different from other mobility modes. For example, car sharing have one usage peak in the evening rush hour, while the bike sharing has 2 peaks in both the morning and the evening rush hours. And the taxi has no obvious peak during the day. And for the per use distance, the car sharing is much longer than the taxis and the bike sharing, which means that the car sharing is different from existing traditional mobility strategies. And finally, based on our mixed methods studies, we extracted 5 categories of user behavior which related to the user behavior. And we extracted 5 categories of features, including the spatial temporal, the historical usage, and the revisitation feature, and user demographic feature, including gender and age, and the contextual features, including, for example, the weather and temperature. And based on these user behavior related features, we then develop a behavior-aware touch boost based method to predict the user's usages. And finally, we compare our behavior-aware touch boost method with other state-of-the-art methods, including convolutional neural network, LSTM, and GBDT, and and RF and graph convolutional network. And we found that our behavioral well-touch boost achieves the best performance considering the MAE and the RMSE. And finally, we summarize some findings and implications. In this work, we report many new findings based on our qualitative and quantitative studies, including people's awareness and purpose and reasons and attitude to use car sharing services. And we also provide some new findings about the quantitative aspect from the spatial temporal aspect and the revisitation patterns and users' age and gender related behaviors. And these findings have the potential to provide guidelines for service station deployment and vehicle rebalancing and pricing mechanism. And finally, we also discuss some limitations and future work. First of all, we only investigate car sharing user behavior in China. The measurement result could be biased due to the particular characteristics of Chinese cities. And another limitation may be that because our survey results might be also biased because the participants are all from China. So the country-specific perception may not be the same as participants in other countries. So in the future, we will perform a large-scale online survey and data-driven investigation to broader users around the world to understand their user behavior. For more data and work, please refer to our website. Thank you very much. And now I'm also happy to take some questions.